Hello, I'd like to demonstrate the attack I'm calling NAT-Again. It should be pointed out there are a lot of mitigations to this attack, and the best one of all is using encrypted IRC. So switch to TLS right now if you haven't already. So for the example here, we have two connections to IRC. We're going to connect as the attacker, and we'll just join a channel. We don't actually have to join a channel, but it's clearer what's going on if we can see. So attacker's connected over here, victim's connected over here. So we're now on IRC. So first of all, just to explain how this attack works a little bit, it uses the client-to-client protocol, which you can ping the victim with. So this is just normal IRC. I can send a ping, and the victim's IRC client basically replies with whatever is sent to it, and the attacker's client, in this case, can work out how long that took and gives you the round trip time. So where this gets interesting is the Linux kernel has a bug in it that when a client is being natted, might find part of a client-to-client protocol command in the wrong place, which means we can trick the kernel into thinking that this client, the victim over here, sent a particular thing when actually the attacker forced them to send that. So just to show first of all, if I, with this, just send a raw IRC message, private message to the victim with control A, ping, and then a number, the attacker's client will send that and the victim will reply. And you can see we get a very weird ping time there because in Irsi's case, this is interpreted as a Unix epoch timestamp, and we've given it a very low number, so that takes a very long time, it thinks, to round trip. So where this gets interesting is if we put something inside the ping packet that is not a number, but is part of a DCC chat message, we can actually get to a situation where we end up with a constructed message. So I'm just going to put this number in here, and then I'm going to pick port 22 because it's a nice number and where SSH runs. So I've now constructed a ping packet that the victim's client is going to reply with no interaction from the victim themselves. And when it replies with that, we'll see what happens. So you see that that reply has come, and you'll also notice that that number has changed, which is part of the interesting bug here. So if I decode that number, you'll see that that is actually the same as that. So we're actually, if we didn't know the victim's NAT host, we would have got it by now, but it's fine, we do know it. So now, if we connect port 22 on that, we can see we've got an SSH banner, which obviously isn't that special, but in this case, I know that is the SSH banner of this machine that is behind NAT, rather than the actual NAT host. So I can just demonstrate that because actually we're running this on a MikroTik router, and it turns out if I run that twice, this time the NAT layer hasn't intercepted the request, and we get the original SSH banner, and we can see that that's a different SSH version. So we've actually, through faking this packet, we've made the NAT host change where the request goes when you connect to port 22, and we've essentially hijacked it. Obviously, this can be used for any port number. One slightly interesting thing is if we use port 0, you see we don't get a reply here. We can see here that port 0 was actually sent to the victim, but we don't get a reply. And this is another flaw in that when port 0 is sent on the connection, Linux can't handle it, and the kernel sits there rejecting the packet. It actually just drops them. So the TCP connection here stalls, and we can see Irssi here is showing that the lag is 2, and that will increase, and eventually this client will just disconnect. So the attacker can also force the victim to disconnect from IRC in a slightly strange way. Hopefully this was useful. Definitely recommend using encrypted connections to IRC, and also upgrade your kernel if you are running vulnerable version.